Installation of a new and sensitive seismometer begins with digging a couple of holes in the ground at a remote Boyd County site. Seth Carpenter of the Geologic Hazards Section, section head Jimmy Wong, and graduate student Andrew Holcomb hauled the instrument, tools, heavy batteries, solar cells, and other hardware to the site for the day-long job. This was the first of a network of instruments installed in eastern Kentucky's Rome Trough geologic structure.
And the reason we're studying the Rome Trough is because there's increased interest in oil and gas, in particular deep shale plays, for example, the Rogersville Shale.
Carpenter had received permission from private landowners to set up these instruments to monitor for earthquakes, including ones that might be caused by the deep injection of waste fluids from fracking operations to recover natural gas.
Many places have run into problems with causing or potentially causing induced seismicity, and they lack background information to compare what they're observing after oil and gas activities start with before, because they don't have observations. So we're being proactive. We're trying to stay ahead of that and installing seismometers to record both natural or man-made earthquakes and to establish hopefully the background signatures.
Once the holes were dug, other labor-intensive jobs had to be completed. The setting up of solar cells to charge the batteries, driving long grounding rods into the earth, and adding an electronics cabinet. Carpenter installed a device to log the data from the seismometer, heavy batteries, other electrical equipment, and a modem to send the information by cell phone network back to KGS.
This is the romantic side of fieldwork.
When sand and a little water had been poured in, the seismometer was lowered about 40 inches into the hole to reduce background noise and to ensure a stable temperature. Then it was carefully leveled and oriented to geographic north. Carpenter says these sensitive instruments record a broad range of ground motions.
They will record weaker motions, and they also will record stronger motions than most seismometers, at least, in fact, all seismometers that we operate. And then also they do that across a broader range of frequencies, from really long period slow waves to high frequency signals. The higher frequencies is really important, particularly for small earthquakes, because they produce more high frequency energy. But also it'll help us to characterize the full waveform, so to speak, from any kind of earthquake that comes through, even from earthquakes anywhere around the world that we can record.
More sand was poured over the instrument to keep it stable before it was buried completely. The recordings from these new instruments can be seen at the KGS website by clicking on our Earthquakes Research link, then the Eastern Kentucky real-time seismic recordings, and clicking on one of the red triangles representing the instrument locations. The display shows one full day of recordings, each line representing 15 minutes.